Hi everyone! Welcome to Senior High School General Mathematics, Quarter 1, Week 2A. Objective: the learner represents real-life situations using rational functions. We have the learning material for this learning activity review. Then for the generalizations, real-life situations involving rational functions. We recall that a polynomial is a monomial or the sum of monomials. For any polynomial, you can write the polynomial function as p of x equals a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus, we have here the three dots. This indicates ellipses. This means that there are still terms in between these two plus signs. And one of these terms here could be either a sub n minus 2 times x raised to n minus 2 plus a sub n minus 3 times x raised to n minus 3 and so on and so forth. Plus, we have here the linear term a sub 1 times x plus the constant term a sub 0, where n is a non-negative integer and the coefficients a sub n minus 1, a sub n minus 2, a sub n minus 3, and so on, up to say a sub 3, a sub 2, a sub 1, up to a sub 0. These are all real numbers. The exponent of the variable in a term determines the degree of the term. In this case, the exponent is n, so the degree is n. The degree of a polynomial is the greatest degree of any term of the polynomial. The terms in the polynomial in descending order, meaning from highest to lowest, by degree, demonstrates the standard form of a polynomial function. A one-variable polynomial in standard form has no two terms with the same degree, since all like terms have been combined. A sub n is called the leading coefficient. The leading term is a sub n times x raised to n, and the constant term is a sub 0. Rational function. A rational function f of x is a function that can be written as f of x equals p of x over q of x, where p of x and q of x are polynomial functions. The domain of the function f of x is a real number except for those which q of x is equal to 0. So meaning, the values of x that will make q of x equal to 0 will not be included in the domain of this function f of x. Example, on any trip, the time you travel in a car varies inversely with your average speed. The function t of r equals 60 over r models the time in hour. It will take you to travel 60 miles at different rates or speed, which we denote as r. How long would it take you to travel with a speed of, number 1, 15 miles per hour, number 2, 20 miles per hour, and number 3, 25 miles per hour? Using the function t of r equals 60 over r, we have to evaluate the one I mentioned earlier. We have number 1, t of 15 miles per hour, t of 20 miles per hour, and t of 25 miles per hour. So for the solution of number 1, we just simply substitute r equals 15 miles per hour in this function t of r equals 60 over r. So let's do this here. We have 60 miles, the distance, over 15 miles per hour, which is the rate. So this becomes, the miles will cancel out. Then we have 60 divided by 15 equals 4 hours. Hence, it would take you 4 hours of travel if your speed is 15 miles per hour. For number 2, we have 20 miles per hour is the rate. So T of 20 equals 60 miles over 20 miles per hour. 60 divided by 20 is 3. Then we have hours as the unit. Hence, it would take you 3 hours of travel if your speed is 20 miles per hour. What if we increase the speed into 25 miles per hour? So we have T of 25 equals 60 miles over 25 miles per hour. So the miles will cancel out. Then what is the greatest common factor or divisor between 25 and 60? So we have 5. So 60 divided by 5, that makes it 12. 25 divided by 5 is 5. So 12 over 5 or 2.4 hours. So we have here, hence, it would take you 2.4 hours of travel if your speed is 25 miles per hour. In this case, time varies inversely with the speed or the rate. Another example, your family decided to go to a travel destination which is 500 kilometers away from your town. Letter A, how long will it take to get to that travel destination if your car's average speed is 25 kilometers per hour, or your speed is 40 kilometers per hour, or 50 kilometers per hour? For letter B, we are to construct a function T of S that describes the time it takes to drive from your town to your travel destination. So we let S be the speed of the travel. For the solution for letter A, we let this working equation T of S or working function T of S equals 500 over S. Then since we are asked to find T of 25, so we have to solve here. T of 25 is equal to, substitute here 500 kilometers distance. Then we have 25 for S. This is kilometers per hour. So we have to cancel out. Then we have 50 and 25. That makes it 2. And we copy 0. So the answer is 20 hours for a speed of 25 kilometers per hour. Hence, it will take 20 hours to travel if your car's speed is 25 kilometers per hour. For another question here, for S equals 40 kilometers, we have T of 40 equals 500 kilometers all over 40 kilometers per hour. So we have to cancel out the kilometers here. Then we have to cancel out 1 0 and 1 0 over here. That leaves us 50 divided by 4 hours. So 50 divided by 4, we reduce it into 25 divided by 2. That's 12.5 hours. Hence, it will take 12.5 hours to travel if your car's speed is 40 kilometers per hour. How about if we have S equals 50 kilometers per hour? So that is T of 50. So we have 500 kilometers all over 50 kilometers per hour. So we cancel out the kilometer unit. Then we have 50 and 50 will cancel out, will give us 1 here. Then we copy the 0, so 10 hours. So T of 50 is 10 hours. You will notice as you go faster, the time that you will spend in traveling will be shorter. As you increase your speed, the time that you will be devoting to that travel destination will decrease. For letter B, construct a function T of S that describes the time it takes to drive from your town to your travel destination. And this given is with a distance of 500 kilometers. We recall that distance equals the speed times time. So in symbol, we denote it as distance, or D equals S times T. And in this case, in the context of the problem, we have the given distance is 500, and that is equal to the speed times the time. So we can interchange by the reflexive property of equality. So we have here S times t, or the speed times the time, equals 500, which is the distance in kilometers. Then we copy this same equation, divide this both sides of the equation by S. So we have t equals 500 all over S. And this is rewritten as t of S in terms of the variable here equals 500 over S. This means that S is the independent variable and t is the dependent variable. Enrichment activity. A high school spends 25,000 pesos each year on student academic achievement awards. The amount spent per award depends on how many awards are given. Write a function that models the relationship between the number of awards A given and the cost C of each award. How many awards are given if the cost of each award is 300 pesos? And if there are 67 awards, how much is the cost of each award? So let us dissect each of the given and each of the question or what is being asked in this problem. So let us dissect this, what to do. So this is the problem I read earlier. Actually, we have to write a function that models the relationship between the given or the number of awards given A, we denote it by A, and the cost C of each award. Another is how many awards are given if the cost of each award is 300 pesos. If there are 67 awards, how much is the cost of each award? So we can concentrate on these three questions. For the solution, we let A be the number of awards is given. Then we let C be the cost of each award. And of course, obviously, it is a multiplication fact that the number of awards given times the cost is equal to the budget of the school, which is 25,000 pesos. Now, we copy this and then let's say we want to have C in terms of A. So, the cost of each award given A awards. So, we can have A times C equals 25,000, then divide this both sides of the equation by A. So, we cancel out the A in the left-hand side of the equation. The right-hand side of the equation is 25,000 over A. That is C. Or we can say C of A, meaning the cost is a function of A. Or meaning the cost is a function of the number of awards A. And C of A equals 25,000 divided by A. On the other hand, we start again with this fact. Then we multiply each side of the equation by 1 over C, or that is simply saying divide both sides of the equation by C. Then we cancel out C here. Then this will give us A, or A of C, or meaning a function A in terms of C, or the value of A when C, the cost of the award, is given. And this is A of C equals 25,000 all over C. We recall that we have A equals A of C. We have 25,000 all over C. Then also these equations. Hence, a function that models the relationship between the number of awards A given and the cost C of each award is C of A. So in this case, we have this function. This is what is asked in the problem. We recall this one, that we have how many awards are given if the cost of each award is 300 pesos. So we are to use A of 300 because the cost is given and A that is what we are going to find. So A of 300, 25,000 divided by 300, So we just have to cancel the zeros here. 2 zeros, 2 zeros, we cancel out. This gives us 250 divided by 3 or 83.3 or simply 83 awards. Thus, there are 83 awards to be given if the cost of each award is 300. And that is with a budget of 25,000 pesos. So this is less than 25,000. We make this award, say 84 awards, we will be more than, or the school will be spending more than 25,000 pesos. For number 2, as radio signal moves away from a transmitter, it becomes weaker. The function S of D equals 1,600 all over D squared relates the strength S of a signal at a distance D miles from the transmitter. For what distance is S less than or equal to 1? Find the signal strength at 10 miles, 1 mile, and 0.1 mile. Solution. We have here S of D given is 1,600 divided by D squared. And this becomes S is less than or equal to 1 according to the problem. For what distance is S less than or equal to 1? So we have S could be equal to 1 or less than 1. So we have 1 is less than or equal to 1,600 over D squared or 1,600 divided by D squared. This becomes 1 times D squared is less than or equal to the same expression that we multiply by D squared. So in this case, we can cancel out this D squared from in the denominator and numerator here. So this will give us D squared. Why? 1 times D squared equals D squared because 1 is a multiplicative identity. So any number multiplied to 1 is always that number. So D squared is less than or equal to 1,600 or 1,600. Then, simplifying this further, we have to take the square root of both sides. So this is here, square root of D squared. Copy the inequality symbol, less than or equal to, then square root of 1,600. Then, we have D is less than or equal to 40. Actually, this is square root of D squared. This means that we have the absolute value of D. It could be either positive or negative. But take note that D is a distance unit. So there's no way for this D to be negative. So positive D should be less than or equal to 40 unit of distance. For S to be less than or equal to 1. S is the unit of strength of a signal. Hence, D is less than or equal to 40 miles. Find the signal strength at 10 miles, 1 mile, and 0.1 mile. We have to evaluate S of 10. We recall that S of D is equal to 1,600 over D squared. And we have S of 10. We just substitute D by 10, then square that. So we have S of 10 equals 1,600 over 100. 10 squared is 100. So we have 16 signal units. So we just have to cancel out the 2 zeros from here and in the numerator. So 16 over 1 is 16. So therefore, this is a symbol for therefore. Therefore, for D equals 10 miles, the strength signal is equal to 16 signal units. What about for 1 mile? We have to evaluate S of 1. So S of 1 is equal to, given the same equation, so S of 1 equals 1,600 over 1 squared, or simply 1,600 or 1,600 signal units. Therefore, for D equals 1 mile, S is equal to 1,600 signal units. Let's evaluate S of 0.1 mile. Okay, with the same given equation or function, we have to evaluate at s equals or at d equals 0.1. So we have s of 0.1 equals 1600 all over 0.1 squared. And simplifying, we have 160,000 signal units. Therefore, for d equals 0.1 mile, s is equal to 160,000 signal units. This ends our discussion for week 2A. Let us now proceed to week 2B. So we have Senior High School General Mathematics. Then we have Quarter 1, week 2B. Objective: the learner distinguishes rational function, rational equation, and rational inequality. The learning material for this learning activity video. Then we have the generalizations. Rational functions, rational equations, and rational inequalities. Rational expression is an algebraic expression whose numerator and denominator are polynomials, and whose denominator is not equal to 0. Rational equation is an equation involving rational expressions. Rational function is a function that can be written in the form f of x equals p of x over q of x, where p of x and q of x are polynomials, and q of x is not equal to 0. Rational inequality is a statement that compares two rational expressions using symbols such as less than, greater than, less than or equal to, greater than or equal to, and not equal to. Let's have some exercises. Directions: determine whether the given is a rational function, rational equation, rational inequality, or none of this. Write your solutions in your activity notebook or answer sheet. So we have numbers 1 to 5. Let's have this in the next slide. For number 1, we have 3x minus 1 over x plus 2 is equal to 2 over x. Since this involves equation or equality or an equal symbol, so this is a rational equation. For number 2, we have x plus 2 over 2x plus 1 is greater than the square root of x plus 2. This is not a rational equation, nor a rational inequality, or nor a rational function. So none of this. For number 3, we have t of x equals 3x squared minus 3x plus 2 all over x minus 5. Obviously, this is a rational function. Number 4, we have 7x is less than or equal to 3x minus 7 all over x. So we have the inequality symbol here. So this indicates that it is a rational inequality. Number 5, we have x plus 3 over 2 is equal to 5 all over x squared plus 2x plus 1. So you have already the hint. This is a rational expression, another rational expression with an equal sign. Obviously, it's a rational equation. If you are not yet a subscriber of my channel, kindly subscribe and please don't forget to like and share. And if you are a subscriber, you will be updated with more uploads for these learning activity videos. Thank you and always stay happy, healthy, and safe.